Yeah, g'day, it's Charlie ZL2CTM. Well, I've had a chance to do a little bit of programming to try and get this cat control software working with the Teensy here. And it seems to be, in fact, it's working well, actually, really well. So what I'll do is I'll just sort of quickly go through in this particular video here, just through the software and what I did. Huge caveat here, I'm not a software engineer, so what I'll show in a sec, there's more than like, well, there will be an absolutely much better way of doing it, but you know, this is the way that worked for me, and I'm purely just putting this video up there that if someone else wants to try and do their own, then you know, here's something that worked for me, and they may wish to tidy it up and make it bigger and better. In terms of the hardware here, just the Teensy 3.6 coming in through the USB port. The screen here is purely for debugging. That won't be required for the main radio. That's just to allow me to do some local printing. And then this one here going to the serial port interface here is a software serial port that's also for debugging purposes. And I'll probably actually leave that in as an unconnected port that if I ever need to do some fault finding on it, I can utilize that. And as you'll see in the code, all that's doing is passing the command it receives from the software, and then it pins onto that command what this radio here, which will eventually be sent back to the software. So in terms of the software itself, just been playing around with the WSJT-X. Hopefully that's relatively clear there. Just, you know, in fact, this is the software I've been using to do all the development for the cat. Under the file radio here, what I elected to do in the end is to, for radio, made the Teensy look like a Kenwood TS480. And the reason why I chose that is because there is readily available online the developers, or the reference, the PC control command reference book for that particular radio, amongst others, which gives you a good rundown of what the command set is, what you will be sent from the software, and how you need to reply. I did find one peculiar problem with this, which if I remember, I'll talk about on the transmit side, and I have a funny feeling it's because this might be for the 480HX, whereas I'm in the software down here on the WSJT was just for the TS480. So that might be why there's a subtle difference there with one particular command which I had to work out. But anyways, the reason why I also chose this is because the command set comes across, in fact if I just nip across to here, you'll see them coming through. This is that software serial port that I'm using to monitor the commands coming in, and sorry, a bit of, hopefully that's clear enough there. I don't have any fancy software here for capturing, so this column here are the commands that are coming in, and these are what I'm sending back out to the radio. So it's asking for a mode, and I'm sending back mode 2, which is for upper sideband. This FA command here with a semicolon, it's always, all the commands are terminated with a semicolon, is what is the frequency on the AVFO, and there it is here. The reason why I chose this particular command set is it's machine readable, well human readable more the point. Yeah, I can read MD semicolon, and it's nice and easy then to refer it back to the reference sheet. Some of the other command sets were a little bit more ambiguous with various bytes that you had to decode to then come up with, you know, what was the command. So in the spirit of trying to keep things simple, I elected to go with that command set, right or wrong. Anyway, so I won't, all I want to say here is that was the radio that I elected to make the software for. In terms of functionality, it seems to work alright. So this is the frequency which it's tuned to. So over here I can change bands. For example, I can go down to the 80 meter band. And if you were just to quietly look up there, you would have seen a command FA and then the new frequency, and then I reply back, this is now what my frequency is for that particular VFO, and that's what the software uses to then update its own display. So it's like a feedback loop, so it knows exactly what the radio is tuned to. So that seems to be working all right. So I can enable tune, and it's now tuning the radio. Enable transmit. That seems, well, in fact, it is working all fine. What I elected to do was not implement. Here we are, we're now transmitting. I'm not actually transmitting as such, but just to prove that things are working fine. Then the various commands up there to put the radio into transmit. Then if I was to cease that now, the commands to put the radio back into receive. So that's working all fine. I was going to say I didn't in the end implement all of the commands called out in the reference document. When I went through those, I got the impression that the software that the radio is being made for, which is this one here, didn't require them all. Should I find some spare time in the near future, I may look to incorporate all of those additional commands. And as you'll see when we go through the software in a sec, that is not difficult to do at all. And one of the advantages of keeping that software serial port open is that if I was to get any errors in any other software, I can read what I was sent, then to work out what I need to actually incorporate into the software. So, a purist, I guess, would have incorporated all of that software all at once, but that's the approach that I decided to take with the available time at this stage. Okay, what I'll do here, rather than trying to explain this on the screen because it's a little bit difficult, I might try and use some software built into Windows to capture the screen, and I'll just sort of race through the code to give a bit of an idea of what I did there. I think the last time I did this, the audio wasn't that flash. Apologies for that, but I think that might be a better way of doing it. So give me a couple of seconds and I'll bring that up. Okay, right, okay, we're back. So, again, before I start, a big caveat there. I'm not a software engineer, so this is the way that I did it. It's a way that it makes sense to me in the way that I think. So that's why I've elected to do what you'll see coming up. Okay, so I won't go line by line. I'll just try and pick on the more salient points. And like I say, well, I've said in the past, I'll put this up on the blog and I'll put that reference in the show notes, and people can do as they see fit. But suffice to say, this is what worked for me. The library is there for the crystal display. Like I said, that's just for debugging and will disappear with the final version. The software serial. Here's an array here, cat command array. So that's 14 positions wide, I guess, or large. That's where, as you'll see further down, the cat commands that are coming in on the serial line are put and then looked at to work out what was asked. You'll see further on down here, I've got a number of variables that assign for each of the frequency divided down. So this is the tens of gigahertz, this is the ones of gigahertz, for example, and as a default frequency, again, just so I could recognize what was going on as data was passed across the line, I've got it set for 14, so 1 in the tens column, 4 in the 1 megahertz, so 14.123456 megahertz. And as you'll see further down, as I want you to change the FEVO frequency A set command comes in, these will be updated to reflect the new frequency that the software wants to see. Most of these variables here for memory locate, well, certainly receive and transmit and VFO and the like, are either a 1 or a 0. And a lot of them actually don't get used at all, but they are required for the command IF, which is the software wanting to know what the status is of the radio. But from what I can see, none of the, or I shouldn't say none, most of these are not actually varied through software. And when I say through software, through the WSJT software. Anyway, start up the objects. I won't go through the setup. That's just basically getting things up and running. The main loop itself here, there's only two functions that are run over and over again. The first one is to actually receive the command in, and then this analyze the cat command. So the first one here, the receive cat command, as I've called it, it's basically just while there's data coming in on the serial port, it's reading that data and dumping that data into that cat command index, as I said, and it keeps on doing that until it sees coming on in this. In fact, where is it? It's looking for the end marker. Now the end marker for a command is that semicolon. So while the end marker up here has not been seen, it keeps on dumping stuff into the index, and when it is seen, it basically puts into that position the semicolon and then moves on. I'll talk about the debug in a sec. That's just purely for debugging and will disappear in due course, more likely. Okay, the next, in fact, and then what it also does here, once it has received that semicolon to indicate that it has received all of the command from the software, it sets this flag to true. So a new cat command is now true. So when we go back to the loop and we loop out of that command or function we've just been looking at, and we go into analyze cat command, which is the next one down here, it will actually enter this if function because it's just been set to true. So if a new cat command is true, please do the rest. In other words, analyze what has been sent. If that was not true, it just wouldn't execute any of this. It would go back to the main loop and keep stuffing that command array with data until such time as it was true. Now that it is true, this particular section here is purely for debugging, so I'm just very quickly dumping onto that my serial port what was received. So I'm just quickly racing through that cat command array, printing it out. I then do a tab, and I just leave it. And as you'll see later on, after that tab will be the command, or more the point to use the proper verbiage, the response that the software here is sending back to the main software, in this particular case the WSJT software. Okay, again, there's probably a better way of doing this, but what I elected to do is just have a series of if functions that it's just goes looking at what's in the very first position, what's in the second position, because those two positions there will have the main command. It's either going to be a get command, so it wants to get something from you, or it's going to be a set command, which is going to tell the software here to do something. If it's a get command, more often than not, the position 0, or that first position in the array, will have a letter, the second one will have a letter, and the third one here will have that termination, that semicolon. In this particular case, it's FA, which is get, so tell me what is the frequency in VFO A. And all I'm doing now with all of these if statements is if this particular this statement here is true, it will then run away and do a number of I don't say subroutines, but other functions. In this particular case, get frequency A. So to race down here, where's my get frequency A? I've been playing around, so these are not in order, which I need to do. So here we are. You don't have to, but it's just the way I like it. Void, so the command get frequency. So I've been asked to send back to the software what my frequency is on the A VFO. And as you can see here, so I start off by saying FA, and then I'm now dumping one by one the frequency of operation, digit by digit, not one big dump. And at the end, sorry, I was just actually thinking, if I was to send it in one big go as ASCII, that would probably actually might work. So I might look into that, but suffice to say for now, this is what I'm doing, and then just finishing it off with that semicolon to basically say, there you go. When I finish this video, I'll actually try that. Anyway, I'm also then sending the same information across that my serial port. So that's it. on the right hand side of that tab, which I mentioned just before, will now be what I sent back. So from a debugging point of view, I can see what was asked for and what I sent back. The only other one I'll sort of point out maybe will be the IF and this FA function here. So this second FA one here is subtly different. I'm looking at the first and the second positions, but I'm also looking at the 13th position, the very last one. And if there's a semicolon in that position, it must have been a set command, because if you look at the reference software, it's FA and then a whole series of digits that represent the frequency. And then the very final position after that would be the semicolon. So I can tell straight away by looking at these three positions here, 0, 1 and 13, that it must have been a set command. So the set command is subtly different. So what I'm doing here, I'm going to update my variables that are containing the frequency digit by digit by digit. And because it's coming across an ASCII, to get the ASCII representation of what it is down to an integer value, I've got to subtract 48. So if you go and look at an ASCII table, you'll see that, for example, 0, the integer number 0 is represented by 48 in the ASCII table. So to get that ASCII back to an integer value, I've got to subtract 48. So what it is, I just go through then looking at those various positions in turn, so position 2, 3, 4, 5, all the way up to 12. I subtract 48 off all of those to get back to what is the integer equivalent, and I dump that into the respective variable there. I then send that back to the radio, because the radio wants to have a response, or the software I should say, the WSJT software wants to have a response after this set command, and that's what I'm doing here. So I send back, here you go, FA, so my frequency in the A VFO, here goes what it now is, and then appended at the end by that semicolon. And that will keep the WSJT software happy, and it will then update its display to basically that feedback loop to show you that yes, indeed, the frequency has actually changed. Again, just dumping it through on the my serial port there, just for debugging purposes. Now, this particular one here, I've just started to think about the calculate frequency, and this is the next function right below that. At some point in time, I need to add to the software the DSP functionality to turn this into an actual radio. At the moment, all the software here is just purely to get the cat functions up and running. But once I do start to add in the DSP side of the house for the phasing receiver, I'll need to change the SI5351's frequency. So I'll need this frequency number here. And all I'm doing now is just converting what is a series of individual digits into one number. So 1 gigahertz, again 10 gigs, or 1 plus 8 times that, all the way down to plus, all the way down to hertz. And that gives me, like I say, one big number, which is frequency. And interesting, at the moment, just to make sure that this logic was working correctly, once I've calculated that, I just dumped the LCD purely for, as I say here, debug printing here. I print out what the individual variables were, and then what I calculated it to be. So I've left in here just I guess to show what my current thinking was and the approach that I took. And I don't know if I mentioned this before, that for me personally, having these sorts of debugging processes, i.e. printing to an LCD something, or sending to the serial port something, is really useful for debugging your program. And I'll quite often have loafing around the code, it just says LCD print line, and I'll just go, I'm here, or here. So I can actually tell, where I am in the actual running of the program. Anyway, that's what that is there. and of course that'll all disappear once I'm satisfied that all of the functionality that I need to run WSJT is actually enabled. And the only other one I'm going to talk about is this IF command here. So this is a get command from the radio, which basically is tell me all about yourself. What is your current status? So as you can see there, it wants to know what the frequency is. It wants to know what your RIT and your exits are. If you're on a memory location, what they are. Are you on transmit or receive? What's your mode? So that's your up sideband and the like, and on it goes. So if you go to the reference guide for creating the software controlled, or in other words CAT, you will see that the P1 through P15 are described in basically what they need to be. And I think that's all I'm basically going to talk about actually. Nothing else. These other commands are quick and simple, and I'll just mention this one here because it's in front of me. The MD, so it's basically a get command, and it's asking for what is the current mode of the radio. So in this particular case, it returns back mode 2. Now the logic will change here. If I was to make this say an upper sideband and a lower sideband radio, then I'd have to have some additional code here that would set, or elsewhere in the radio, set the MD to 1, 2, or the like. At this stage, this is purely just to get things up and running, and it's only going to be upper sideband, so I'm going to leave it as it is. But that's why that is. Okay, right. So like I say, that's just, I guess, trying to describe how I approached it, right or wrong. It's working well, and I will now move on to adding in the DSP side of the house, and we'll continue developing it. We'll see where we go. Okay, cheers all 73s, and we'll see you next time.